Assalamu alaikum. Welcome back to my video series on data science. Today we have reached step 8, model deployment and integration, one of the most exciting phases of data science process. In this video, I will show you how to make trained models from Keras, Scikit-learn and PyTorch and deploy them into real applications. We will also walk through creating a simple Tkinter GUI, integrating your model and turning your solution into a usable application. Let's bring your model to life. First, let's see how can we save and load models in Keras, PyTorch and Scikit-learn. Let's start with Keras, which makes saving models super simple. Model.save. This one line saves everything, the architecture, the weights and even the optimizer state. .h5 is the extension for HDFS file format. If you want to save just the weights, maybe because you plan to tweak the architecture later, use this model.saveweights. It will only store the weights, not the model architecture. To load the full model back, use load model function. But if you have only the weights, first you need to create the model and then load the weights using the load weights function. Next, let's see PyTorch, where model saving is a bit more manual but flexible. If you want to save the entire model, you can use torch.save. The model will be saved as a PTH file. To save just the weights, not the complete model, you can use model.stateDictionary. After loading the model, always call model.evaluate to make sure the model behaves correctly during the inference. Now let's talk about Scikit-learn. Here model saving is straightforward using job library. You need to first import job_lib and then using the dump function you can save the model. The model extension is .pkl, that is a pickle file. And to load it back you can use joblib.load function. Unlike Keras or PyTorch, Scikit-learn does not support saving just the weights. Now let's move from just training model to actually using them in a real application. In this part, we are building a simple desktop application using Tkinter where we will load a retina image, run it through our trained segmentation model and then display the predicted mask, all in a simple user interface. First, we need to load the saved model. So these are the libraries that we require. So here is our model architecture. We use unit for the image segmentation task and this is the code for the unit. This is the code for the evaluation metric, that is actually IOU metric that we use to evaluate our model. And here's the function, a method to create the model. In this function, we are setting the optimizer, setting the loss function and the evaluation metrics and creating a model, compiling it and then returning it. So first we'll call this function create model to create a model so that we can load the saved weights into it. Then comes the GUI part. We start by importing the required libraries, Tkinter for the GUI, PIL for the image processing, and of course NumPy for the numerical operations. This gives us all the tool to interact with files, resize images and display them properly. Here we define a getModel function that loads our pre-trained model weights. Make sure your model architecture is already defined elsewhere in your code. This just loads the learned parameters, not the entire model. We pre-process the retina image before feeding it to a model, converting it to a grayscale, resizing it to 512 by 512, normalizing the pixel values and reshaping it to match the model's input shape. After the prediction, we post-process the mask, squeezing it to 2D, scaling it back to 0 to 55 and converting it to an image that can be displayed. Now we define a segmentation app class to build our GUI. It includes a button to select an image and two image containers, one for the original input and one for the predicted mask. Once an image is selected, we pre-process it, run the prediction and then display the both original and the predicted masks side by side. Finally, we launch the application using the tk.tk main loop. Alright, now let's see our segmentation app in action. I will go ahead and click the select image button. This opens up a file dialog where I can choose any retina scan image from the system. Once I select an image, the app automatically pre-processes it, feed it to our trained deep learning model, and display the results. On the left, you can see the original retina image, and on the right is the segmentation mask predicted by the model. The model highlights the blood vessels as the area of interest. This is especially useful in medical imaging where quick, automated segmentation helps assist doctors in diagnosing the condition more accurately and efficiently. And that brings us to the end of the step 8 in our data science process, that is model, deployment, and integration. In this video, we explored how to save and load models in Keras, PyTorch, and Scikit-learn. Then we took it a step further by integrating a trained segmentation model into a simple Tkinter GUI. We saw how a deep learning model can go from raw code to a usable application where anyone can select an image and instantly get predictions, no technical details needed. Model deployment is where your hard work meets the real world. Whether it's through a web interface, mobile app, or desktop tool, integration is what turns model into impact. If you found this video helpful, don't forget to like, share, and subscribe for more videos on data science and AI.